Welcome to day 2 of the circles unit. Today we're talking about finding arc measures and using inscribed angles and polygons. First, we need to cover over some definitions. First is central angle. A central angle is an angle whose vertex is the center of the circle. So in this case, ACB is the central angle. A minor arc is an arc that measures less than 180 degrees. A major arc is an arc that measures more than 180 degrees. And a semicircle is an arc that measures exactly 180 degrees. Its endpoints are the endpoints of a diameter. The measure of an arc is equal to the measure of its corresponding central angle. In this picture, arc RS has its corresponding central angle is RPS. RPS has a measure of 110 degrees. So therefore, arc RS is 110 degrees. Now we know a circle has 360 degrees. Okay, if we're looking for arc RTS, so we start at R, we pass through T, and we stop at S. Well, we know RPS is 110 degrees, so we can take 360 and subtract the part that we know, which is 110, and we come up with 250 degrees. RST, start at R, pass through S, and stop at T. You notice RT is the diameter. And whenever it has endpoints that are a diameter, we know that it's a semicircle. So RST is 180 degrees. Adjacent arcs are two arcs that have a common endpoint. In the arc addition postulate, the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So basically we're adding the two angles together to create the sum of the arcs. In this picture, TQ right here has the central angle of 120 degrees. So if the central angle is 120, then the arc is also 120, which makes it a minor arc. QRT, so we're starting at Q, we're passing through R, and we're stopping at T. So this missing piece of the circle is 120, so we can take 360, subtract 120, and we get 240, which is a major arc. TQR. Well, TR is our diameter, so it has two endpoints that create the diameter, so it's a semicircle, which is 180 degrees. QS. Now we have to find this missing piece right here. So we know that TR is a semicircle, and we know that TS is 80 degrees, so we can take 180 and subtract 100, or subtract 80 to get 100 for angle RS. So from Q to S, we have 60 and we have 100, so QS is 160 degrees, which is a minor arc. TS, like we just said, has the central angle of 80 degrees, so arc TS is 80 degrees, which is a minor arc. And RST, again, R and T are the endpoints of our diameter, so we know it's a semicircle, which is 180 degrees. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. In this picture right here, this little angle is our inscribed angle. The intercepted arc is the arc that lies in the interior of an inscribed and has endpoints on the angle. So here is our intercepted arc right here. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. In example 3, find the indicated measure. Okay, we're looking for angle T. Well, here's angle T. It's an inscribed angle, and its intercepted arc is RS, which is 48 degrees. So we take 48 and we divide it by 2 because it's half, and we get angle T to be 24 degrees. Now, arc QR is a little bit more involved. First, we have to find QT. Okay, QT, since angle R is 50 degrees, we know that QT is going to be 100. Okay, and TR is our diameter, so this creates a semicircle. So QT plus QR is going to be 180 degrees. So we take 180 and subtract QT, which is 100, and we're left with QR as 80 degrees. Example 4 says find the measures of arc RS and the measure of angle STR. First, let's find arc RS. Here's arc RS, and its inscribed angle here at angle U is 31 degrees. So 31 times 2 gives us the intercepted arc, which is 62 degrees. Now to find STR, STR is also an inscribed angle with RS as its intercepted arc. So 62 divided by 2, again, STR is going to be 31 degrees. And what do we know about STR and RUS? Well, they're congruent. Next, if two inscribed angles intercept the same arc, then the angles are congruent. Find the measures indicated. FGH. Well, HF here is our intercepted arc, and G is our inscribed angle, so 90 divided by 2 gives us 45 degrees. Now, arc TV has an inscribed angle of 38 degrees. 38 times 2, arc TV is 76 degrees. Over here, WXZ is what we're looking for. Well, we know that YWZ is 72, okay, which means WZ is its intercepted arc. 72 times 2 is 144. WXZ also has an inscribed angle that opens to WZ. So 144 divided by 2, again, is going to be 72 degrees. Example C here applies to this theorem. If they intercept the same arc, then the angles are congruent. So this one's 72 and this one's also 72. A polygon is an inscribed polygon if all of its vertices lie on the circle. The circle that contains the vertices is a circumscribed circle. The theorem is if a right triangle is inscribed in a circle, then the hypotenuse is the diameter. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Example 6 says find the value of each variable. Now again, we got to remember we have a quadrilateral whose opposite angles are supplementary. So in this case, x plus 80 should add up to 180 because they're supplementary. So subtract 80 from both sides, x should be 100. Same thing with y. Y plus 75 equals 180. Subtract 75 from both sides, you get y equals 105. In example B, 2a plus 2a equals 180. So 4a equals 180, which means a equals 45. And B, 2b plus 4b equals 180. 6b equals 180, which means b equals 30.